This is my presentation on comparative forecasting of financial time series, evaluating traditional machine learning and deep learning AI models from the S&P 500. So this is my thesis and like the main purpose of the project, and it's to investigate whether advanced machine learning, deep learning models, or the traditional models are best at forecasting time series. So for the traditional models, we just have the standard ARIMA model. And for the machine learning, we're using gradient boosting, XGBoost, and light GBM. And for the deep learning models, we're using LSTM, GRU, CNN, and a CNN LSTM hybrid. And we're running these models on historical S&P 500 data. So for for these models, we're going to evaluate them based on accuracy, variance, and like the stability across models. And the purpose is to identify which models are best and most reliable at predicting those stock trends. So these are the models that we're going to be running, and we're comparing them based on the errors using the RMSE and MAPE. So this is a graph of the ARIMA model, and what this does, it's like a best fit line, so it's not very accurate at all. As you can see, it has like no variance, and yeah, it's just kind of like showing the general trend of the data. And for the gradient boosting, you can see it has a lot of the variance, but it's also just like off by like a big margin. And these are the machine learning models. So like for all of them, like for the gradient boosting, the XG boost, and like the light GBM, you can see that they capture like the variance of the data, but they do not capture, well, it's not like precise. And then moving on to like the deep learning models, we have the LSTM, and these models, they are more accurate than the machine learning models, but they show less of the variance. So as you can see, we have like the CNN LSTM, and finally the GRU. So overall, the GRU is the best one because it is very close to um, the actual price of the stock compared to the other models. And here is like an overlay of our top models compared to the actual model. And so in conclusion, Um, the ARIMA model is stable, but it just shows like the general trend, so it's not very accurate. The tree-based models, also like known as the machine learning, are good at um, predicting like the variance and stuff, but they are generally like a little bit off the actual uh, predicted price. And the light GBM perform the best out of all the machine learning models. And for the deep learning models, they're more accurate, but they require more tuning and computation to calculate the variance of the data. So overall, the deep learning had the best accuracy. Well, but like the machine learning models are often like simpler and faster, but they're not as accurate. So in the end, the machine learning models, especially the GRU, was the best model.